Alrighty, so we are going to be starting 12.8, which is the volume of similar figures. And so this is going to involve things like scale factor. Again, we've done similar figures in triangles. Back in first semester, we did similar figures with area and surface area. So we're going to be continuing that trend. So first thing we need to do is identify if two shapes are similar, or if they possibly are even congruent or neither. So to determine that, we have to look at their measurements. If they're similar, there's going to be some sort of ratio or scale factor that we can use that will determine that we can multiply the same number to all of the links that are provided and get the same result. Or if they're congruent, then all of the side links that are provided for us are congruent. Or if they're not, neither, if there's no number that works as a scale factor or scale factor ratio that works for these problems. So the first thing I'm going to do is go through and just identify the side links that are provided for us. So I have 42 on the left, or 4.2 on the left, and 4.2 on the right for the radii of these two cones. And then I have 12.3 on the left and 12.3 on the right. So it looks to me that these are congruent. So these have identical lengths of sides or measurements that are provided for us. So they are, in fact, congruent. There's no number that's necessary. 4.2 is equal to 4.2. 12.3 is equal to 12.3. So there's no, if they were similar, then we would come up with a ratio, but if they're congruent, we don't have to do that. So we'll look at the next problem. Okay, so here we have a few different side lengths. I have the 2 meters, and the matching piece is 1 meter. And then we have 2 meters on the bottom and 1 meter on the bottom. And then we have 4 meters and 3 meters. So what we need to do is check to see if there is a same number that is used for each of these to show that we can multiply the same number to all the pieces to get the same result on the other side. So I'm going to start with our 2 meters to 1 meter. 2 times 1/2 is going to give me that 1 meter. The same is going to go for the 2 meters to 1 meter on the bottom. 2 times 1/2 is going to give me 1. And then I need to look at the 4 to 3. So 4 times what is going to give me 3? Well, that's going to be 3 over 4. So we need to look at what we are multiplying by in each one. If they were all the same, then these are similar, but I have 1/2 and 3/4. So I'm not multiplying by the same thing at all. So these actually would be neither. So they are neither similar nor congruent. So if I was looking for something that was similar, we would have a similarity ratio. So let's look at another problem, see if we can find that ratio. So if I look at these prisms, I'm going to compare sides. So I'm going to take that 3 and match it up to 4.5. And we would say that 3 times some sort of scale factor is equal to 4.5. And we would need to check all of the provided measurements. So 5 matches up with where 7.5 is. Some sort of scale factor is 7.5. And then we would take 4 to 6. So 4 times some sort of scale factor will equal 6. So I'm going to use my calculator, see if I can find that scale factor. 6 divided by 4. So that scale factor is 1.5 or 3 over 2. 1.5 divided by 3. That again gives me the same scale factor of 1.5 or 3 over 2. And 1.75 divided by 5 also gives us the same scale factor. So since all three of these have the same scale factor, we can say that they are similar. And so their similarity ratio would be 1 to 3 over 2, or 1 to 1.5. You might have ratios that are 1 to 6 or 1 to 2. It just depends what your scale factor, what you're multiplying by is. And so that is how we find that. One clue I want to give all of you is think about spheres. The only unit of measure that we use for spheres is the radius. So if you're comparing two radii, are you always going to be able to find some sort of scale factor because you're taking one radius and multiplying it by something to get a new radius? So that's just a little thought to keep in your mind as you're working through these problems. Now we have to take into account, how do we do scale factor with volume? Well, if you remember when we did scale factor for surface area, for area in general, what we had to do, we have to think about how are we handling those dimensions? What's happening to the units when we are giving our final answers? So if we look at this little table here towards the bottom, we have to think about when we're doing scale factor for just one side, we take the old dimension, which is like a side or radius, and we multiply it by scale factor and get the new dimension. That's what that little star means, is multiply. For your surface area or area, remember we did scale factor squared to get your new surface area, because let's see, this is in units, centimeters, inches, etc. When you're doing surface area, you've got units squared, centimeters squared, inches squared, etc. I can't write today. ETC, there we go. And then so when you take into account volume, well, volume, our units we have learned are cubed. Centimeters cubed, inches cubed, etc. So if you follow this pattern, when you're doing scale factor with volume, you're multiplying by scale factor cubed. So whatever our scale factor is, we're going to have to cube it in order to find our answer. So we'll see how that goes.